Hi, PerspectaWeather.com meteorologist Paul Dorian here on Wednesday, April 24th. Tomorrow happens to be Bring Your Child to Work Day, and Perspecta will certainly participate. So I thought I'd devote this morning's video discussion to any student out there in high school or junior high school who may have an interest in meteorology. We'll talk a little bit about the field of meteorology, what potential colleges one can go to major in meteorology, some of the career paths that one can choose. We'll even go through a real-time weather forecast for the next couple of days using some of the various tools available to a weather forecaster. Real-time data analysis that can produce a surface weather map, for example, radar and satellite images, and an important tool to weather forecasters are computer forecast models, and there's a whole wide range of computer forecast models from all over the world. Finally, we'll take a look at the Perspecta Weather website that has a page called Meteorology 101 that has all kinds of video discussions on a wide range of meteorological topics that may be of interest to some of you interested in the field of meteorology. Well, what is the definition of a meteorologist? If you do a search on the definition, you'll find quite a variety of definitions. Some that just say a weather forecaster. That is not specifically an accurate definition of a meteorologist. You can be a meteorologist without being a weather forecaster. I like a simple definition, one that specializes in atmospheric processes. In college, you'll learn all about different processes involved in the atmosphere, some that produce upward motion, some that can produce an increase in winds, and all of these have an impact on the weather and important roles in weather forecasting. If you are a student in high school or junior high school and you think you have an interest in meteorology, one of the things I want to stress right here is that math and science is crucial. If you enter meteorology as a major in college, your first couple of years will be devoted to math and science. Specifically, in terms of science, you'll study a lot of physics. In terms of math, calculus. You'll have differential equations for much of the time in the first couple of years. In fact, a meteorology major ends up taking as many math courses as a typical engineering student. In terms of colleges, I have a list here, and I'm certainly not saying this is the entire list. This is just a list off the top of my head of many of the colleges. I went to Penn State University. Penn State is well known as a meteorology school. It's been in the field of meteorology for more than 75 years. In parentheses here, I have perhaps the specialization of this particular college in terms of the field of meteorology. For example, Penn State, it's a great school to go to if you're interested in weather forecasting or doing television. Penn State's been around a long time, as I said earlier. In fact, anywhere from 15 to 18% of all meteorologists in the country have a degree from Penn State. University of Wisconsin is another very good school in meteorology. By the way, some of these schools use the term meteorology as a major, others atmospheric sciences. Wisconsin, for example, it's the Department of Atmospheric Sciences, whereas at Penn State, it's the Department of Meteorology. Wisconsin has a good emphasis on satellite meteorology, so if that's a specific area you want to go into, that might be a good school for you. Now, this doesn't mean that Penn State doesn't deal with satellite meteorology. They do, and Wisconsin certainly deals with weather forecasting as well. Other areas, Purdue, out in the heartland, out in Indiana, they have a lot of farms out there, and they specialize in agricultural meteorology. Weather is critical to crops, from coffee beans down in South America to corn out in Iowa. The weather is critical, and you learn a lot about that at Purdue. Some of these other colleges I have listed here have specialties basically because of their location. Florida State University is quite a good school to go to if you're interested in hurricanes. Of course, Florida is one of the main states in the U.S. impacted by hurricanes every tropical season. Out in the Tornado Alley area, Norman, Oklahoma, is where NOAA, the government agency for weather, has its storm prediction center, because Oklahoma is right there in Tornado Alley. Texas, Oklahoma, Kansas, and the University of Oklahoma specializes in severe weather. In fact, the University of Oklahoma is kind of intertwined with the Storm Prediction Center of NOAA out there in Norman, Oklahoma. If you're really interested in staying in the Mid-Atlantic region, for example, southeastern Pennsylvania or near D.C., there are other schools like Millersville University, University of Maryland, Rutgers University up in northern New Jersey. In fact, if you really look at it, if you take a look at the Big Ten Conference, you have a lot of schools in meteorology. Penn State, Wisconsin, Purdue, Maryland, and Rutgers, all part of the Big Ten. Just so happens they're pretty strong schools in meteorology. Other areas, University of Washington, MIT up in New England, Texas A&M, Albany, State University of New York at Albany is a good school in meteorology as well. And again, this is not an all-inclusive list. This is just some that came to the forefront of my mind. And I attended Penn State University years ago. In terms of different career paths one can take or different roles for meteorologists, it's not only weather forecasting. In fact, you can go into meteorology and not be a weather forecaster. Certainly, that is a large part of the field of meteorology. But if all you like to do is code, computer programming, you have a lot of opportunities in meteorology. Computer forecast models are a critical tool used by weather forecasters, and they require coding. All kinds of computer programmers work in the field of meteorology. You can't just stick to research at universities, for example, or at government institutions like NOAA and NASA, and specialize in case studies, for example, on how things may impact weather forecasting. But you can certainly stick to research, or you can go into teaching at universities, for example. If you have an interest in teaching meteorology at a university, chances are you may require a PhD. You don't necessarily require a PhD if you just want to do weather forecasting, for example. I have a BS and an MS from Penn State. All kinds of weather forecasters out there in the field that do not have a PhD. But if you plan to teach at a university, PhD certainly would help. In terms of employers, government, the NOAA and NASA are two huge employers of meteorologists. NOAA is the National Oceanic and Atmospheric Administration. NASA, National Aeronautics and Space Administration. Both involve satellites. Both have satellites. That's why NASA's involved in meteorology, and NOAA has all kinds of meteorologists all across the country. But they're both of these, NOAA and NASA, have a lot of people working in the Washington, D.C. metro region. Of course, there are private weather forecasting companies. AccuWeather, for example, they actually are located up in State College, Pennsylvania. There are many other private weather forecasting companies. NOAA has the National Weather Service. Those are federal weather forecasters. And again, there are private weather forecasting. Defense, intelligence, and military community. Certainly, they all have some meteorologists, and universities finally has plenty of meteorology people working in the field of meteorology, either teaching or doing research at universities. Perspecta has dealt with the defense, intelligence, military community, as well as some university interaction, and Perspecta has some work at NOAA and NASA as well. So we kind of involve a lot of this here at Perspecta, which has locations all around the country. Headquarters of Perspecta is in Chantilly, Virginia. I work out of a Valley Forge, Pennsylvania office area for Perspecta. Well, let's get into the real-time weather forecast for the next couple of days. And I'm looking here at a surface weather map. We do a real-time analysis of temperatures, pressures, winds at all weather stations across the nation to come up with a surface weather map like this that has cold frontal systems right here, for example, and low pressure areas. And this particular low pressure system right here in Texas is actually going to make a move to the north and east over the next couple of days. Looks like it'll bring some rain to the Mid-Atlantic region of Philadelphia and D.C. from later tomorrow right through the day on Friday, after a pretty nice day today following the passage of this particular cold frontal system. This is moving through right now. It'll be cooler today in Philadelphia and D.C. and New York City compared to yesterday. with a bit of a northwest breeze, but this is the area of concern for Thursday night and Friday. Well, here's another very valuable tool to the weather forecast, radar images, and in this particular case we have a loop of radar images. And notice here, first of all, in the mid-Atlantic region, no echoes are showing up. Echoes will show up as green if it's rain, or snow is depicted here in blue, and an ice mixture of sleet or freezing rain, pink or purple in this particular case. This radar loop, by the way, from Intellicast.com. Notice down here across Texas, a lot of green and some yellows and oranges showing up. That represents some heavier rainfall. That is, again, the area we're looking at over the next couple of days. It looks like dry today here, no radar echoes showing up in the mid-Atlantic region, but this is all moving to the north and east, and looks like it'll bring rain here to the mid-Atlantic region Thursday night and Friday. Well, here's another very valuable example of a tool used by a weather forecaster, the satellite image. This particular satellite image comes from what's called the GOES-16 satellite put up by NOAA, and it is a crucial tool for the weather forecaster. First of all, this is what we call a visible satellite image. Notice Pennsylvania, for example, in the clear. No clouds for the most part across Pennsylvania right now. Sunny skies quite likely later on today. Tonight, clear skies will give way to clouds. Notice here to the south and west, especially over Texas. We saw the radar echoes a moment ago, and here is a cloud patch associated with that low pressure area we saw in Texas on the surface map. And then we saw all those radar echoes, greens, yellows, and oranges in Texas. And here is the cloud band associated with that particular storm system. Again, all of this headed to the north and east. So it looks like these clear skies will give way later tonight and especially early tomorrow to clouds. And then rain is on the way for later tomorrow night, and especially during the day on Friday. Well, another very important tool of the weather forecaster is what's called the computer forecast model. There are many, many computer forecast models out there. In fact, many countries have their own forecast models. The U.S. has what's called the GFS, a global forecast system produced by NOAA. That is more of a wide scale or synoptic scale type of computer forecast model. We call it basically a global model. There are smaller scale or mesoscale models out there. NOAA's #1 mesoscale model is called the NAM model, the North American Mesoscale Model, more devoted to smaller scale processes. Not only does the U.S. Have its own computer forecast models, but the United Kingdom has one known as the UK Met. Europe, the European Weather Agency, has its own model known as the European model. Japan has its own model. Canada has its own model. If there's anything, there's too many models out there for the weather forecaster to take a look at. There's sometimes too much information is not necessarily a good thing. We also have models that are devoted to specific types of events, like hurricane models that are specifically geared towards the atmosphere surrounding a hurricane. This particular model that we're looking at right here, the model output from the GFS model, again produced by NOAA here in the U.S., and we'll kind of go forward for the next couple of days and see what the computer forecast model predicts. Basically, it starts off with as much real-time data as possible. That's surface weather observations at all the weather stations around the world, and upper air data is collected through the usage of balloons, radiosonde balloons, that are launched at various sites around the world. And as they rise up through the atmosphere, they collect data on temperatures, pressures, and winds. All of that upper air data, surface data, is fed into a computer forecast model, and then equations are used to crank through with time as a variable in those equations, and you can get a 12-hour forecast of temperatures, pressures, humidity, for example, winds, 24 hours, 48 hours. This particular model actually goes out 384 hours, 16 days out. Of course, the accuracy of a computer forecast model diminishes the farther and farther out in time you go. This is the way the computer forecast model looks this morning for Wednesday morning. Greens represent areas of rain, blue, snow. Here we are in Pennsylvania right here in the clear right now in terms of precipitation. But let's move forward here. By the way, these particular maps available from a website called tropicaltidbits.com. Again, it's a forecast model generated at NOAA here in the U.S. And let's move forward here now by this evening. And the time is up in this area right here. This is Wednesday evening, still in the clear here in terms of precipitation in the Mid-Atlantic region. But notice this area of precipitation, rainfall in this case, pushing to the north and east. And here we go. By tomorrow afternoon, some showers possible in D.C. and Philadelphia. And then we move even farther ahead and we have a soaking rain event, it looks like, later tomorrow night into the day on Friday. That low pressure area that this morning is in Texas moves north and east to West Virginia by early Friday morning. Continue ahead here, and even some heavier rains predicted by this particular model for Friday afternoon, Friday evening. So there can be a thunderstorm mixed in as well. So certainly this computer forecast model is giving us a rain event beginning as early as tomorrow afternoon, Thursday afternoon in Philadelphia, D.C., New York City, but more likely later tomorrow night and during the day on Friday. And some of that rain could be heavy at times. It looks like it gets on out of here by Saturday morning. This is now Saturday morning. It's like a windy day, but mainly a rain-free type of day after that rain event ends early Saturday morning. Well, one last thing I wanted to show was the PerspectaWeather.com website. We have a page called Meteorology 101, and there's a whole series of video discussion, maybe 5 minutes long, 10 minutes long, on a whole wide range of topics that may be of interest or may get a student interested in meteorology. And to get to that particular page, go to the home page on the PerspectaWeather.com website, scroll on down and click on Meteorology 101, and that'll take us to this particular page that has numerous topics discussed here. Upward motion in the atmosphere. Again, we talked about atmospheric processes crucial in the field of meteorology. One of the things you learn about at college when you take meteorology courses. And again, the meteorology courses dominate the 3rd and 4th year of college. Math and science, specifically physics and calculus, the first couple of years at college. And here we go, all kinds of storm development called cyclogenesis here, a video discussion on that. We talk about some space events here, including the solar eclipse, the big total solar eclipse of a couple of years ago, sunspots, and again, a focus on computer forecast models that require computer programmers, require all kinds of knowledge of differential equations, for example. We talk a lot about that in these particular video discussions. Again, they're 5 or 10 minutes long. Weather has an impact on all kinds of things, including how far a baseball can travel. We have a video discussion on weather and the home run right in here. Basically, the warmer and more humid the air mass, the farther a baseball can travel. So it's easier to hit a home run on a hot and humid August night, for example, compared to a cold day in April. And we talk a little bit about that. So just wanted to point out this particular page on the PerspectaWeather.com website called Meteorology 101 that may get a student interested in the field of meteorology, because weather has an impact on all kinds of things, again, from the growing crops anywhere around the world to the flight of a baseball on a hot and humid night in the month of August, for example. If you have any questions, feel free to go to the About page on the PerspectaWeather.com website and shoot me an email. This has been a video discussion geared towards students, especially high school students and junior high school students who may have an interest in meteorology. That's it for now. For PerspectaWeather.com, I'm meteorologist Paul Dorian.